Hello, and welcome to the AWS Storage Virtual Workshop Series. As mentioned, this is episode 5, Amazon S3 Security, Stay Secure on Amazon S3. My name is Lee Keir, and I am a Senior Storage Specialist Solutions Architect with AWS. Joining me on the chat is Scott Franks. Scott will be doing 2 of the interactive demos that we'll be seeing a little bit later, and he, as well as Fatima Kamandine and Russ Boyer, will be answering your questions as we go along. We'll also be putting some documentation into the chat at various points during the workshop, but please don't read the documentation during the workshop. I don't want you to miss anything. So if you're watching the recording, the documentation will also be listed below. Now, before I begin, I would like to level set on what to expect from this workshop. This is a 200 level workshop. So we expect that you will have some familiarity with S3 and with security generally, but nothing more is expected. So if you're hoping to learn about S3 bucket policies and how to use them for your S3 data, this workshop is for you. If you're hoping to learn about preventing public access to your S3 buckets, encryption options, and the best practices for data protection, you're in the right place. Now, if all of that sounds like old hat and you were hoping to dive deep into advanced security topics, well, this may not be what you're looking for. But if you stick around, I think that here's our agenda for today. We're going to start talking about S3 access controls and boundary enforcement. And then Scott will give us an interactive demo to explain some of those concepts a little more deeply. Then we'll talk about encryption options, security and compliance monitoring, data protection. We'll have another demo, then we'll wrap up and do our Q&A. So today we're going to be looking at the 2 parts to permissions. We call this the shared responsibility model. So your job is specification. You define what entities are allowed to perform which actions on which specific resources and under what conditions. And AWS's job is enforcement. For each request, the service or application evaluates the permissions that you defined whether to allow or deny access. So let's look at the S3 access controls. There are 6 types of access controls we're going to talk about today, but we're actually just going to concentrate on those top 4. We'll talk about AWS identity and access management, and this is how you define what a user can do on AWS. Then we'll talk about S3 access control list, and this is a way you can grant permissions to either a user or group of users to either a bucket or an object. Then we'll talk about S3 bucket policy, which is a way to define both cross-account access and then also how this bucket can be accessed. We'll then talk about VPCE endpoints, which is a way to define the connections between your EC2 instances and VPC all the way to S3 without going outside of the network. And then we'll talk about S3 access points are a named endpoint that are attached to buckets that you can use to perform S3 object level operations, get and put, but not bucket level operations. And access points can be especially helpful if you have different types of access required for the same bucket. Now, they're beyond the scope of this workshop, but we will be putting some documentation into the chat if you want to learn more about S3 access points. And AWS service control policies are a type of organization that is a type of organization policy that you can use to manage permissions in your organization. Now, SCPs offer central control over the maximum available permissions for all accounts within your organization. Permissions are not granted by an SCP. Rather, attaching an SCP to an AWS organization entity, whether that is root, an organizational unit or OU, or an account, actually defines guardrails or sets limits on the actions that the IAM users within that account can perform. So we're going to start talking about IAM and IAM user policies and S3 bucket policies. So when you create a bucket in Amazon S3, the owner of the bucket is the account which creates the bucket. So users within that account that have IAM policies which allow actions can perform those actions against that bucket. So if as a user in my account, I create a bucket Any other user in that account who has IAM policy, which allows them to perform those actions, would be allowed. So we'll take a look at the structure of these policies in just a minute. But first, let's talk about the difference between IAM policies and a bucket policy. So as I said, an IAM policy defines what a user can do within AWS, and an S3 bucket policy defines who can access this S3 resource and how. So by default, users have no permissions. So IAM user policies are about adding the permissions that user can do. And it controls all AWS services. So it's not just S3, but EC2, EBS, RDS, CloudFront, and so on. And then S3 bucket policy controls how the bucket is accessed. And we're going to go into a lot of detail on this, as well as a way to grant cross-account access to your S3 bucket without using IAM roles, which is another option that we won't go into. And then, of course, buckets are private by default, as I already described. Only those users within the account that creates the bucket have access to the bucket. Now, if you haven't seen an IAM or a bucket policy before, here's what they look like. They start off with a version, which is a date that is for that version of this policy. It hasn't changed in quite a while. We'll see that in a minute. And then you have one or more statements. And each statement has different parameters that are possible. And we're going to go over each one of those now. The first one is effect. And effect is either allow or deny. That's it. Those are your only two options. It's either allow or deny. Very easy. Now, our principal defines the entity that is either allowed or denied. In this case, we have an ARN, which is just an Amazon resource name. And here it is, ARN : AWS : IAM : 1234567891012 : user/username. So this is a user within that account, and the username is username, which is probably a bad one to pick, but it shows it as the username. Now, the action can be any type of action that is allowed or denied via the service. In this case, we have S3 get object, and we're using that a lot. And then the resource, this is the Amazon resource that will be acted upon. In this case, our ARN is ARN : AWS : S3 : my-bucket /prefix /dar. So that would be the bucket of my-bucket, and then the objects that begin with prefix /. And so any object that begins with prefix / would be the resource that we're talking about in this particular access policy. And then conditions. I love conditions. Conditions allow you to take the context of the request and then make decisions about that. So the context of the request is various elements of the request, including the IP address that the request is coming from, the principal that the request is coming from, the type of request, the options within that request. For instance, are you asking for encryption to be done? Is there a tag on this object already? Are you coming in at HTTP or HTTPS? All of those things are the context of the request, and you can have conditional statements about them. So in this case, we have not IP address, AWS source IP 52.230.33.0/24. So within this subnet, if it is not within the subnet, then this condition would result to true. Okay. Now, how do we actually process these requests? Well, we start off with the request context that I just talked about, all the unique components about this particular request. And then we start off with a decision of deny. Just start there. And then we evaluate all the applicable policies. We take the IAM policy, the bucket policy, the VPCE endpoint policy, the object ACL, and we evaluate them all at once. There is no order. There is no hierarchy. We take them all at once. And then we say, is there an explicit deny? If there is an explicit deny, then the final decision is deny. That's it. You're done. If there's not an explicit deny, then we look to see, is there an allow? If there is an allow, then the final decision is allow. And if there is not an allow, then the final decision is deny. And that's how it works. Very, very straightforward. Now, here we're going to look at two example IAM policies and bucket policies. And one thing that, look at the IAM policy, you will notice it does not have a principle or a condition. Now, principles are not put onto IAM policies. Why? Because the principle is the account to which the IAM policy is attached. Right? So it's implied. You can take the same IAM policy and attach it to multiple principles, and each time the principle would be the account to which it's attached to, or the user or role. So let's take a look at this IAM policy. We have our version, which is single date, which is 2012, 1017. Our statement is effect, allow, SID. Oh, we haven't seen this before either. What's that? That's a statement ID. Okay, so the statement ID is allow, write, and read. And it is a good practice to put into your SID what you expect this policy to do. That way you can compare it with what you expected it to do with what it actually does, and make sure there's no disconnect there. So our actions are S3 put object and S3 get object, and our resource is our AWS S3 : mybucket /star. Okay, so these are objects within that bucket, and so our actions are put and get objects, so those object level actions, and so we have an object level resource. Okay. Now let's look at let's look at our Amazon S3 bucket policy. This bucket policy allows a principal from AWS account 1111111111 to read objects from my bucket. But the condition limits it to objects that have a specific tag value. So let's take a look. Our version is going to be the same version as always. Our statement is effect, allow, principal, AWS, and our account number. Okay. And our action is get object. Our resource is mybucket /star. I'm not going to list the whole ARN thing every time, just the bucket part. So mybucket /star, so objects within my bucket. And my condition is string equals S3 existing object tag project X. So that would mean that there is already a tag on the object where the name is project and the value is X. So that would limit this user to be able to only get objects that have that tag. Okay. Now we're going to look at a couple more IAM user examples. Just to kind of get you familiar with how this works. So here's a user policy that allows this particular user to put, get, and delete objects to the test-bucket, list objects in the test-bucket, and also allows access to the S3 console. So here we have again our version, and then we have statements. But this time we actually have two statements. And so that's how you would do multiple statements within the same policy. So here our first statement is effect, allow, action, S3 get bucket location, and S3 list all my buckets with resource star. So in this case, we don't know what the name of the bucket is going to be. So we have to have the resource as star. And this is the part that will allow you access to the S3 console, because in order to access the S3 console, it has to list all those buckets in order to display them. Now, the second statement here has effect, allow, action, S3 list bucket, S3 put object, S3 get object, and S3 delete object. So we have both our list bucket is a bucket level operation, and those other three are object level operations. So our resource is then test bucket and test bucket /star. So the test bucket without slash and star, that's the bucket level. So that's for the list bucket. So we have our list bucket goes against the bucket, and then the other from that. Now here's another example. In this example, we allow all actions to all buckets, but we explicitly deny from one bucket called customer. So we again have our version and our statement. And in our statement, we have a SID of full access. Our effect is allow, our action is S3 star, and our resource is star. Now, to be clear, this is very, very permissive. And we would not recommend that you give this to anyone except your highest administrators, because you want to make sure you limit that. And in fact, in an advanced level, we may want to limit that even more. Now, so in other words, this does allow this user to do actions against any bucket within the account. Now, the other statement, SID deny customer bucket, effect deny action S3 star, and resource customer and customer /star. So it's denying any action either at the bucket level or the object level for the customer bucket. And if you remember that if explicit denies are evaluated first, this would deny all access to that bucket. So now let's talk about Amazon S3 Access Control List. So an ACL can be applied either at the bucket level or at the object level, and they can only grant access. You cannot deny access using an ACL. They're written in XML format and have some predefined groups. So you can either assign to a particular user or account, or you can use some of these predefined groups like all users and any authenticated users. But you want to have a lot of care when using these, because all users is anyone on the internet, and any authenticated user is anyone with an AWS account. Okay. So do be careful with those. The ACLs do have a finite set of permissions compared to policies. We have read, write, read ACP, which is access control policy. So this is how you read an ACL, write ACP, writing an ACL, and full control. And we'll talk about full control in just a few minutes. And for buckets especially, we really want to prefer using bucket policies over bucket ACLs. They're just so much more granular, and there's so much more you can do with them. So when you allow another account to put objects into your bucket, the account that uploads the objects retains ownership and control of those objects. In order for the bucket owner to access the objects uploaded by another account, the uploading account must add an ACL, bucket owner full control. This gives the bucket owner permission to the object, but not ownership of the object, which means that the bucket owner could not then share those objects with others using a bucket policy. Until now. On October 2nd, 2020, S3 released a new per bucket setting that enforces uniform object ownership within a bucket. With this setting enabled, objects uploaded from another account with the bucket owner full control ACL will be owned by the bucket owner. Because this setting changes the behavior seen by the account that's actually doing the uploading, the put request must include the bucket owner full control ACL. So we recommend that you use a bucket policy that requires inclusion of this ACL. Here is just such a policy. So here we have our version. Our statement is SID require bucket owner full control. Our effect is allow. Our principal is our AWS user. This is the same. It's just another way to express the user that we had before. So this is that account of 111.111.111.111. And the action is S3 put object and S3 put object ACL, because this user will have to put an ACL, so we'll need to put that as well. And then it's to my secure bucket / star. So this is object level operations. And our condition string equals XAMZ bucket owner full control. So if that ACL is not included with the request, then this request will be denied. Now, many AWS services deliver data to a bucket of your choice, and these are now equipped to take advantage of this feature. Those include S3 server access logging, S3 inventory, storage class analysis, AWS Cloudtrail, and AWS config. They can now all deliver data that you own. You can also configure Amazon EMR to use this feature by configuring it in the cluster configuration. Do keep in mind that this feature doesn't change the ownership of already existing objects, but also note that you may now own more objects than you owned before, which may change some of the numbers that you see in your reports or other metrics. So we've talked about ways to control who has access to your bucket from using IAM policies and bucket policies. But what about those cases when you want to allow someone who may not even have an AWS account to get or put objects into your bucket? Say a customer of your photo sharing website who wants to upload a photo. Or maybe you have some content that you want to provide to a customer, but only after they've authenticated to your website. You can provide them with a pre-signed URL to get or put to a specific object in your bucket. When you create the pre-signed URL, it will use the permissions of the IAM user that creates the URL. You need to provide your credentials, the bucket name, the object name, whether it's a get or a put, and the expiration date and time. Until this URL expires, anyone with the URL can perform those actions. So if you send it to someone, they can send it to someone else, and they can then use it as well. So you need to think carefully about how long you want a pre-signed URL to be valid. So let's move on and talk about boundary enforcement. So what is boundary enforcement? Boundary enforcement is like guardrails, putting a boundary around what is allowed. Now, AWS SCPs are a great example of how to create boundaries. Say, for example, your company is based in the US, and they've decided that they only want resources to be created in US West 2 and US East 1. You can easily create a SCP policy that would prevent anyone in the organization from creating any AWS resource that was outside of those two regions. It's a boundary that no one can cross. Now let's dive deep into the two other types of boundary enforcement: VPC endpoints and S3 block public access. So prior to the release of S3 Virtual Private Cloud Endpoint, or VPCE, if you wanted to access your S3 bucket from within your Amazon VPC, you had to create an internet gateway in order for EC2 instances in your public subnet to be able to access S3's public IP addresses. And if you had a private subnet in your VPC, you had to also create a VPC NAT gateway so that traffic could be routed to the S3 public IPs. So with the release of Amazon VPCE, you can now access S3 without using NAT gateways or internet gateways, allowing you to stay wholly within the AWS network. Now, the endpoint has a policy that controls the use of the endpoint to access Amazon S3 resources. The default policy allows access by any user or service within the VPC using credentials from any AWS account to any S3 resource, including S3 resources for an AWS account other than the account for which the VPC is associated. Also note that S3 VPC endpoints do not support cross-region requests, so make sure that your bucket is in the same region as your VPC. If you use other AWS services in your VPC, they may use S3 buckets for certain tasks. Ensure that your endpoint policy allows full access to Amazon S3, which is the default policy, or that it allows access to your specific buckets that are used by these services. Alternatively, only create an endpoint in a subnet that is not used by any of these services to allow the services to continue accessing S3 using the public IP addresses. So we're going to put some documentation into the chat about which services have this issue. There are 9 services, and so you'll be able to see that there. So now let's look at some policies, though, for these S3 VPC endpoints. So remember that the default policy allows access by any user or service within that VPC, using credentials from any AWS account to any S3 resource. But unlike bucket policies, where you allow external accounts and deny access actions you don't want, the VPC policies, you have to allow everything that you want to be able to do from that VPC. So it's important to think about how you want to restrict this access. So let's take a look at this VPC policy. Looks a lot like our bucket policies, I know, but this is a VPC policy. You can tell by the little VPC icon. So the version is going to be the same, and we have an ID, and this is just another optional parameter. And let's look at our statement. We have our SID, access to specific buckets only, effect allow, principal star, so any principal, and our action is S3 get object, S3 put object, and S3 list bucket. And we list my secure bucket, so for bucket level operations, and my secure bucket /star for our object level operations. All right, so from this VPC, going to this VPC endpoint, you can only get to this one bucket, and you can only do these actions. Right? It's really locked down. Now, maybe you want to do something different. Maybe you want to only allow put object, but to anyone in our organization to be able to do this. So let's take a look. We have our version again and our statements. Statement has a SID of principal only from my org, effect allow, principal star, action S3 put object, resource my-secure-bucket /star, and the other bucket /star. So we're going to allow actions to these 2 buckets. So we're going to allow put to these two buckets, but we have a condition of string equals AWS principal org ID O-1A, 2B, 3C, 4D, 5E. So anyone who is in our org will be allowed to put objects to these two buckets. Now you can also lock down to the bucket to say that it's only allowed to be accessed from that VPC or VPCE. So in this case, we're restricting access to a VPCE. And you can see we again have our version and our ID. And with our statement, we have our SID of access to specific VPC only. Our effect is deny principal star action S3 star and resource my secure bucket and my secure bucket /star. So we're going to be denying any action where our condition is not true. And our condition is string not equal AWS source VPCE, VPCE 1A, 2B, 3C, 4D. So this means that no action will be allowed to this bucket if you're not coming from that VPCE, which also means, by the way, you would not be able to do any console requests to this unless you were actually coming from within your VPCE. So do be careful about that. You can lock yourself out. All right, now we're going to talk about block public access. So what is public access? Public access is any anonymous or overly permissive access, right? So if you have any of that, we'll consider that public. And there are two ways we look at this. One is through an ACL. For example, access control list with all users or any authenticated user, right? This is essentially anyone on the internet or anyone with an AWS account. We would consider that public access. Similarly, if a bucket policy has overly permissive access, we would consider that public. So let's take a look at these two. We have effect allow, principal star, action S3 put object, and resource star. So this will allow anyone to put objects into this bucket. Okay, that's pretty much public. And then our second one, effect allow, principal star, action S3 get object, resource star, condition string like AWS source VPC, VPC dash star. So this would allow anyone coming from a VPC. By the way, you will notice this is different from a VPCE. It's very similar. You can restrict to either a VPCE or to a VPC. Okay. But this would allow anyone to get objects who's coming from any VPC. So this is also considered public. Now, any of the explicit cross-control access that we've talked about in some of our other policies is not considered public access. Okay. Now, in 2018, S3 launched S3 Block Public Access. It's a set of 4 security controls that you can apply to your bucket or an account. And these settings override the ACLs or bucket policies that might have granted public access to your bucket or objects. Now, we highly recommend that you enable block public access at the account level. When you turn on block public access at the account level, newly created buckets in that account will have the BPA or block public access enabled automatically. So you don't have to enable each bucket, and new buckets are automatically protected. Now, if you do have a need to have a bucket or multiple buckets that have public objects, put that bucket or buckets into a separate account, maybe label it with public data or something so that everyone knows that if you put data into this account, there is a possibility that it'll be public. And then all of your other accounts in your organization should have block public access enabled. And when you're using AWS organizations, you can set up a service control policy to prevent anyone from changing these block public access settings, even for the root user. So let's take a look at these settings. First one is block public access to buckets and objects granted through new ACLs. So essentially what this does is if you try to upload an object with a public ACL, then that request will be denied. Or if you try to upload an ACL to an existing object that is public, that request will be denied. So second one is block public access to buckets and objects granted through any ACL. So this means if you already have an object with a public ACL, then access to that object will be blocked. block public access to buckets and objects granted through new public bucket policies and access point policies. So we haven't really talked much about access points, but they have policies. They're just very similar to bucket policies. And if you try to create either one of those that is public, then the putting of those policies will be denied. And finally, block public and cross-account access to buckets and objects through any public bucket or access point policy. So if you already have an existing bucket policy or access point policy that grants public access, then that request would also be denied. All right, and we've reached the point for our interactive demo, so Scott's going to do that, and take it away, Scott.
All right. So looks like my screen is available. So what I am in right now is our S3 console. What I've done is I've configured, we come back here to kind of the S3, the root level of the S3 service. I've got 4 buckets configured. Like Lee just talked about, I have actually turned on bucket level block public access, so that you'll see that these cannot be public. These 2 buckets. These are my logging buckets, which we're going to discuss later. So what we're going to do right now is actually set up a static website using the feature, that feature in AWS, and we're going to use this one right here. And so what we want to do is come to our permissions. We're going to use a bucket policy for this. So I'm going to set up a bucket policy. But I don't want to type all that JSON myself, so I'm going to use a tool that we provide called the policy generator. So we're going to select an S3 bucket policy to now allow. Now this is for a public website, so this is going to be one of those public policies that we really want to do in very limited situations. And then what I want to do here is to get object, and our ARN is going to be this guy right here. Only what I want is the object inside that bucket. So now I'm going to add a statement, and I'm going to generate the policy. So now there is one manual step here to this process. I've generated my code. You can see all the parts that Lee's talked about. I've got my SID, I've got my version ID, which is and then an ID. And my effect is to allow objects from this bucket to all principals. So I'm going to copy that. And I'm going to close that. We're going to come back to our bucket policy here. And I'm going to paste that now. I'm going to save that bucket policy. And now watch what happens here. You'll notice that S3 is telling you, hey, you just made this accessible to the world, and we highly recommend that you not do this. We warn you here, we warn you in the bucket policy control itself, and we warn you in the tab where you select permissions that this bucket has policy. So we say that security is job 0, and this is really we are really going out of our way to make sure that you understand this is a public policy. You're going to see that continues. So what I would like to do now is come over here to properties. And I'm going to post the, let's see, static web hosting website in our chat. Or somebody's going to, we're going to post the website in the chat. Is that, Lee, could you do that? Or can somebody who's on screen do that? We're going to post this website in the chat. And while I'm going to wait a few minutes and ask some of the people in the audience to go ahead and hit that website and see if it's returning a message. Actually, I can just do it here too. So this is actually the website, and there it is. So you'll notice that I've notified you inside the website that block public access is off. So now this is what we've kind of showed you. What I've showed you here is what not to do. So now what we want to talk about is what to do, and what our recommendation is, and Lee just mentioned this in her, is to block public access at the account level. So I'm going to turn on block public access very quickly. Boom. And I'm going to block all public access to all objects in this account. So no buckets, even though they may have settings that say that they are allowed. This is an explicit deny at the account level. Remember that the statements that are when we evaluate our security statements, we look for an explicit deny first. So any explicit deny is an absolute deny. So now that I've done that, if I come back here to my website, I have got an access denied. So what I'm going to do now is show, we talked about the pre-signed URL. So I'm going to have to get out of my full screen here for 1 second. And I'm going to generate a pre-signed URL, and I think Lee or somebody else is also going to generate one in the chat room. And we'll ask you to go ahead and give that a try as well.
Yeah, that's been posted, Scott.
Okay, great. Just going to grab the one that I've got here. So here is my pre-signed URL. This is actually to, did you do the index.html or did you do the football, Lee? So anyway, so here's an example of a pre-signed URL into that same web server. If you go way back to the front of it, you can see there's a lot of tokenization that we use to provide the security. But if you go all the way back to the front, you can see that we're in the same region, in the same bucket. That's not going to be... So that's our pre-signed URL, and I think that's it for the first demo. So back to you, Lee.
Okay, thanks, Scott. All right, so now we're going to talk about encryption options. So within AWS, we look at two different types of encryption. We basically break it down into encryption in transit and encryption at rest. So encryption in transit or data in motion, is the data actively moving to and from S3 over the network. Now, it's a best practice to require encryption in transit, and I'll show you a bucket policy in just a minute to do just that. And we recommend you use TLS 1.2. Now, if you're using the AWS SDK, it will automatically be using the TLS 1.2, so you don't need to worry about that. Now, in encryption at rest, we also break this down into two categories. You have client-side encryption, which is where you encrypt the data before sending to S3. And you can use the AWS Encryption SDK to take advantage of the AWS Key Management Service, or KMS, in order to manage your keys, rather than having to manage them yourself. Now, on the server side, we also break this down into three categories. We have SSE S3, where the S3 service itself manages the key rotation. You don't have to worry about that, and it's totally free, very simple to use, and therefore it's widely popular. Now, if you have your own corporate standards around how you do key rotation and you want to control which keys are used to encrypt which objects or buckets or prefixes, then you want to use SSE KMS, using our key management service, as I talked about just a second ago, talking about client side. Now, if you want to, what it allows you to do, it allows you how to define when you want to rotate your keys, and also to put in a policy to restrict who can access those keys. It's another kind of IAM resource policy, similar to the bucket policies we've looked at, that you can add to KMS to restrict who can use that key for encryption and decryption. In other words, you can have separate controls over who can encrypt and decrypt objects apart from the controls of the bucket policy. And then we have SSEC, which is customer provided keys. In this case, each request would actually have the master key that you want to use for encryption within the request, S3 would then use that key to encrypt the object and then throw that key away. So when you want to decrypt this object and retrieve it, you would need to provide that same key in order to unencrypt that object. So as promised, here is the example of a bucket policy to restrict access to only HTTPS and TLS. So let's go through it. We have a version again of, it's the same date as always, and then our statement. We have a SID of enforce TLS connections, effect, deny, principal, star, action, S3 star, resource, mySecureBucket, and mySecureBucket/star. So for any operation from any principal, we're going to deny if our condition is not true. And our condition is a Boolean. AWS, which is essentially just a true-false. AWS secure transport, false. So if this request comes in over HTTP, then this would resolve to true, and the request would be denied. Now, S3 also provides default encryption at the bucket level. You set it up on your bucket one time, new objects that come into that bucket. And you can set it up to either do SSE S3 or SSE KMS. So customers often have compliance requirements that all objects in their S3 buckets be encrypted. So a common question would be, what about the objects already in my bucket? Well, there's a very easy way to verify the encryption status of all of your S3 buckets via the S3 inventory report. Now, the S3 inventory report can be generated either daily or weekly, and it's an inventory of all the objects in your S3 bucket. And you can do it either at the bucket level or the prefix level. And the inventory includes the key names, the object size, the versions, the storage class, as well as the encryption status, the replication status, and the object lock status. We'll talk about those last two in a minute. But this makes it a very easy way to verify the encryption status of all of your S3 objects. Now, the inventory includes whether the encryption status is SSE S3 or SSE KMS. So then you could filter out all the objects that have those encryption status, and then you would be left with a list of unencrypted objects. And then you can use that list as an input to S3 batch operations, where you can perform a copy to the object of the same name. In other words, you just copy it to itself. And assuming that default encryption is enabled, all of those objects would be encrypted as they are copied. Note that this will update the timestamp on these objects. So let's talk about security monitoring now. So it's not enough to set the right security settings once. You need to verify that those settings remain set correctly. And these 4 features and services that are provided do just that. The top 2 listed here are free, and these allow you to verify that you have no public access to your buckets. And the bottom 2 do have some costs, but they provide more features. So bucket access control view in the S3 console, Scott showed us this earlier. This is totally free to everyone with an AWS account. We want it to be easy to see and verify that you do not have public access to your objects. Now, the AWS Trusted Advisor is an online tool that provides you real-time guidance to help you provision your resource following AWS best practices. Trusted Advisor checks help optimize your AWS infrastructure, increase security and performance, and reduce your overall cost and monitor for service limits. There are several AWS Trusted Advisor checks that are totally free to all customers with any level of support. One of those checks is the S3 Bucket Permissions check, which will alert you if there are any public objects in your buckets. And you can opt to receive a weekly email with the status of all of your checks, and it's totally free. AWS Config enables you to assess, audit, and evaluate the configurations of your AWS resources. AWS Config monitors the resource configurations, allowing you to evaluate your recorded configurations against the desired secure configurations. And AWS Config provides several, 14 at last count, managed rules related to S3 security. They include checks for public read or write access, checks to verify that versioning, logging, replication, or encryption are enabled, and a check to make sure that your buckets are configured to only allow HTTPS TLS connections. AWS Config is a powerful tool for your organization, But unlike the previous two checks, the use of AWS config is not free. There's a small cost. Now, in July 2020, we released Amazon Guard Duty for S3. The anomaly and threat detection for Amazon S3 activities that was previously available in Amazon Macie has been enhanced and reduced in cost by over 80% as part of Amazon Guard Duty. This new capability enables Guard Duty to continuously monitor and profile S3 operations, including S3 configurations, in order to detect suspicious activity, such as requests coming from an unusual geolocation, disabling of preventive controls, such as S3 block public access, or API call patterns that are consistent with attempts to discover misconfigured bucket permissions. Now, to detect these possibly malicious behavior, Guard Duty uses a combination of anomaly detection, machine learning, and continuously updated threat intelligence. When threats are detected, Guard Duty produces a, let's try that again. So sorry. When threats are detected, Guard Duty produces a detailed security finding to the console and to Amazon Event Bridge, making alerts actionable and easy to integrate into existing event management and workflow systems. So there's a 30-day free trial for Amazon Guard Duty for S3. And during this trial, the estimated cost of your S3 call volume will be determined and will be put into the Guard Duty console in the usage tab. In this way, you can evaluate the capabilities of Amazon Guard Duty for S3 for free, and then know exactly what your cost would be going forward. So monitoring configuration is important, but to audit your S3 usage, you need logging. You can record the actions that are taken by users, roles, or AWS services on S3 resources and maintain log records for auditing and compliance purposes. And to do this, you can use either Amazon S3 server access logs or AWS Cloudtrail object level logging. So service access logs, just that. It's a record of access attempts made against objects in your bucket. This is managed and maintained by the S3 service alone. You cannot filter what events are logged. However, it logs events that are also not logged by AWS Cloudtrail and has some fields not logged on Cloudtrail. You can send logs to a central bucket, but only within the same account. And you do want to send all your logs to a central bucket and then don't log that bucket. You don't need a log of your logs. You can enable this for free, but you must pay the S3 fees for storing of the logs. Now, AWS Cloudtrail object level logging records API activity to the Cloudtrail service. Cloudtrail is the AWS API auditing service, and object level logging allows you to incorporate S3 object access to your central auditing and logging in Cloudtrail. You do have the ability to control what buckets, prefixes, and objects will be audited and what type of actions to audit. And it will incur additional Cloudtrail charges. So both Cloudtrail and S3 server access logs can be used to audit and gain insight into the actions that are being performed on your bucket. But which one do you choose? They both have their advantages, and I would recommend both. But if you do have to choose, AWS recommends using Cloudtrail as it integrates with your other AWS Cloudtrail logs and can be centrally managed within your organization. However, if you need to audit lifecycle transitions, glacier restores, or want to calculate the total size of objects being requested for your S3 bucket, then you want to enable S3 server access logs as well. So we'll be posting in the chat a comparison between these two services. So in this workshop, when we talk about data protection, I want to be clear about what I mean by that. We're not going to be talking about backups or disaster recovery. We're going to be talking about protecting the access to your data and preventing accidental and malicious deletions. So just like with AWS permissions, data protection in S3 has two parts: the infrastructure and tools that S3 provides, and what you need to do to take advantage of these AWS tools. So let's start with what Amazon S3 provides to all S3 data. Durability. All Amazon S3 storage classes are designed to provide 99.9999999% durability of objects over a given year. That's 11 nines of durability. So to put that into perspective, if you were to store 10 million objects with Amazon S3, you can expect, on average, to incur the loss of a single object once every 10,000 years. That's right, 10,000 years to expect a loss. So how does S3 do it? S3 redundantly stores your objects on multiple devices on a minimum of 3 availability zones within an Amazon S3 region before returning success. So Amazon S3 also uses a combination of content MD5 checksums and cyclic redundancy checks, or CRCs, to detect data corruption. S3 performs these checksums on data at rest and repairs any corruption using the redundant data. In addition, the service calculates checksums on all network traffic to detect corruption of data packets while storing or retrieving data. This makes sure that the data you send is the data that is stored. So you don't need to worry about S3 losing your data, but you do need to take steps to make sure your data is not accidentally or maliciously deleted. This is very important because if you delete a non-version object, it cannot be recovered. I'm going to repeat that. If you delete a non-versioned object, it cannot be recovered. So let's look at our best practices to prevent accidental and malicious data deletion. So we'll start with versioning. Versioning is at the core of all of these features. And in fact, it is required for the other 3 features that are listed here. So then we're going to talk about object lock, which is a way to set an object to not be allowed to be deleted until at least a certain time or indefinitely. Now, multi-factor authentication delete adds another layer of protection for deleting objects or changing the versioning state of a bucket. With MFA delete enabled, you need 2 forms of authentication: to delete an object or to disable versioning on the bucket. The second form of authentication is either a virtual or a physical authentication device to create a one-time password. If you need to delete an object from an MFA delete enabled bucket, you will need to supply your credentials, and the additional authentication of the serial number from the MFA device and a one-time password. I do know of several customers who turn this on and then just store that device in a safe with no intention of ever using it. And then replication. They're either cross-region replication or same region replication. And for this, we want to concentrate and make sure that we have cross-account replication to protect ourselves against rogue actors. So, as I said, S3 versioning protects you from accidental deletions of S3 objects, and you can turn on versioning either on a new bucket or an existing bucket. And you can use versioning to archive all previous versions of an object and easily restore them to recover from unintended user actions or application errors. So let's take a look at an example. So we have our object here, and if we put it in our version-enabled bucket, it now becomes photo.gif version ID 1. The version IDs are not single-digit numbers. They are much bigger. We'll show you those in a second, but this is just for this demonstration. So if we then overwrite this object or put another object of that same name, S3 retains the previous version, so you can restore it if needed. So now we have photo.gif version ID 2. This is now the current version of this object, and photo.gif version ID 1 is the non-current version. So to help protect against accidental deletes, when you delete an object in a version-enabled bucket, S3 does not remove that object. Instead, S3 inserts a delete marker, which now becomes the current version of the object. If S3 receives a GET for this object, it will return a 404 not found unless you specify the version ID. And you can always restore or permanently delete the version or previous version by specifying the object ID in your request. And also you should use S3 Lifecycles to transition current or non-current objects to a lower storage class or delete them if they're no longer needed. Obviously, if you were to keep all your versioned objects forever, that cost would be unreasonable. So let's take a look at the console where we can see that we have our versions, and you see them right there in the middle, the little circles. You can hide or show the versions. And you can see here we have our example with 4 versions. The top one there from August 4th is the latest version. And you can also see that our version IDs are not single digits, but rather 128-bit UUIDs. And there you also notice that the third object down is actually a delete marker, and that's what those look like. So as I said, to help save on cost for storing versions of your objects, the best practice is to use a lifecycle policy to expire previous or non-current versions after a set period of time. So if you look at the area in blue, you can see we have non-current version expiration of non-current days 7. Now, this is not the age of the object, but the number of days that it has been non-current. Okay. And this is a way to set up a kind of a recycle bin so that you have time to determine that you've accidentally deleted something and then have time to restore that. Also, if you do get into that situation, suspend your life cycle so that it doesn't accidentally delete something out from under you while you're trying to restore. Now, you can also use Amazon S3 Object Lock to store immutable objects using a write once, read many, or worm model. And it can help you to prevent objects from being deleted or overwritten for a fixed amount of time or indefinitely. You can use S3 Object Lock to meet regulatory requirements in the financial or the healthcare sector that require worm storage. Or you can just add an extra layer of protection against object changes and deletions. So when an object is locked with a retention period, that object then has a new property, the retain until date. This date defines until when this object is immutable. And it can be applied either when you're putting the object or it can be added after the fact. It can even be changed, but only moved out further in the future. And there are 2 modes of protection, either compliance mode or governance mode, and we'll go over those in just a minute. But before you can lock any object, you have to configure a bucket for S3 Object Lock. So here's some things to know about that. You can only enable Object Lock on new buckets. If you want to turn on Object Lock on an existing bucket, please contact AWS support. When you create a bucket with Object Lock enabled, Amazon S3 automatically enables versioning for that bucket, and you cannot disable Object Lock or suspend versioning for that bucket. When you turn on Object Lock for a bucket, the bucket can then store those protected objects. However, that setting alone does not automatically protect objects that you put into the bucket. If you want to automatically protect object versions that are placed into the bucket, you can configure a default retention period. Default settings apply to new objects that are placed into the bucket unless you explicitly specify a different retention mode or period for the object when you create it. It's similar to the way default encryption works. The default is used unless it is specified in the request. So to audit the object lock status of objects in your bucket, you can turn on S3 Inventory Report. I mentioned inventory earlier, in the inventory report earlier when we were talking about encryption. So it includes the retain until date, the protection mode, and the legal hold flag, which I'll talk about in just a second. In this way, you can verify the status of all of the objects in your bucket. So there are 2 modes of the retain until date protection, and they are governance mode and compliance mode. So in governance mode, you can have a privileged user who can modify those retention controls if you do find that you don't want to keep that object for that entire period that you have locked it for. But with the compliance mode, you cannot. So you should use compliance mode if you have a requirement to store compliant data, and you should only use it if you never want any user, including the root user of your account, to be able to delete objects during the predefined retention period. Now, you can escalate from governance mode to compliance mode. So you may want to do that if you want to test out how your object lock is working, make sure you've got it set correctly, and then move to compliance mode if you have that requirement. Now, the legal hold flag. So we pick the name legal hold, but really it's for any situation where you're not sure how long you want objects to remain immutable. So it's a Boolean, a true, false. It can either be on or off. And it can be applied or removed using a new API that can be restricted to via IAM. So legal holds are independent from retention periods. Placing a legal hold on an object version doesn't affect the retention mode or the retention period for that object version. For example, suppose you place a legal hold on an object version while that object version is also protected by a retention period. If the retention period expires, the object doesn't lose its worm protection. Rather, the legal hold continues to protect the object until an authorized user explicitly removes it. Similarly, if you remove a legal hold from an object version that has a retention period effect, the object version remains protected until the retention period expires. How long you want to retain an object, use governance mode, or compliance mode if you have a compliance requirement. And if you don't know how long you want to retain an object, use legal hold. S3 replication is an automatic and asynchronous process that makes identical copies of your data, retaining all the metadata from the source object, including the object create, date and time, and the version ID. Now, since cross-region replication launched in 2015, customers have used it to replicate trillions of objects and exabytes of data for a wide variety of use cases. And there are many reasons to replicate your data. But today we're going to focus on replication for data protection. So let's take a look. You can replicate your data either in the same region or a remote region. And you can replicate to a bucket with object lock enabled. So you could create a bucket with object lock enabled and a default retention period, and all objects replicated to that bucket would have object lock for the time period configured on the destination bucket. Now, suppose you also had a requirement for predictable data replication and need visibility into Amazon S3 replication times. Amazon replication with time control can provide metrics and an SLA that 99.99% of objects will be replicated within 15 minutes. S3 replication time control includes replication metrics, which can monitor the total number of S3 API calls that are pending replication, the total size of the objects pending replication, and the maximum replication time to the destination region. So let's take a closer look at how you can configure S3 replication for data protection. So S3 replication gives you the choice to replicate either the entire bucket, a set of objects under a given prefix, or individual objects that you identify with tags of your choice. So once you've selected your source data set, you select a destination bucket in the region of your choice. And you can make the replication data more secure by using object ownership override and cross-account replication. Ownership override will take any object that has been uploaded by another account and make that object owned by the owner of the destination bucket. So if you have a bucket where you've allowed cross-account access, those objects uploaded by that account will now be owned by the destination bucket owner. And cross-account replication is a best practice as it means you're protected if a rogue actor compromises your account for the source bucket and starts deleting all your data. They will have no ability to delete the data in your destination bucket. So depending on the use case for your replicated objects or replicas, you can choose to keep them in a frequent access storage class or replicate them directly into an infrequent access or archive storage class such as S3 Glacier. Because the data access patterns are often different between the source and destination buckets, it's a best practice to specify different lifecycle policies on your source and replica objects to optimize cost based on their individual access patterns. Replication begins as soon as you upload an object to S3 after you have configured the bucket for replication. So objects that are already in the bucket when you create a replication policy will not be replicated. If you need to replicate these objects, contact AWS support to enable replication for these existing objects. Okay, now Scott's going to give us another demo.
So once again, we're back to our bucket, our S3 console with our 4 buckets. Like I said, I actually created 2 logging buckets for this demo because for points of clarification. I want to examine the server access logs first. They're in this workshop logs bucket. So what I've got here.
Scott, can you magnify your screen again? Can you enlarge your screen?
Yeah. By the way, does this sound better?
Yeah, I think so. Okay. For me, it is.
Okay. So here's my here's the server access logs that have been generated in this for these in this bucket or in this workshop, and we want to open one of these and examine exactly what's in here. You know what? Oh, I don't know why that's not. You know what? I think because I'm going to try this again without block public access on. I think that may be prohibiting. I don't have an explicit allow for my account, so let me turn this off just for a second to see if that's what's keeping us from getting those. Let's try that. Okay. Oh, you know what? So let me make this a little bigger so you can see it. So you see this is a standard server access log. You get a lot of the same things that you would get from a web browser. If you've ever looked through a web browser log, you get TLS version, you get source IP, time, exactly the get and put of the object. So you're getting exactly the same type of thing that you'd get from any other type of static, HTTP request log. This can be very helpful for audits. That sometimes some audits actually require these types of logs because they're that way you have parity between all of your different services. But for this, we have the R and we've got a lot of data here, but it is it's fairly generic. So now let's compare this to the Cloudtrail logs that we have for this account. So the Cloudtrail logs are stored in a hierarchy. These are the prefix hierarchy. So it's account name, account number, Cloudtrail, and then by region. And let's look at I think the 12th, just to be sure. Cloudtrail can take some time to propagate, so I'm going to work off of a see if I can make this. Nope, can't zoom on that one as easily. See if I can make this full screen and maybe, no, it's still going to be really hard to read. But basically, if you can see that you're going to get a lot more of the actual API calls from the Amazon account. So you have for instance, you have your account ID. Here, you've got the type, the bucket, and the ARN still, but you also have more explicit information about the API calls, the signature, and the trackability. So once again, this gives you a more robust data data flow, and gives you more tools, but it is more precise for the S3 experience. So the next thing we wanted to look at is we talked about Trusted Advisor. So Trusted Advisor is a service that you can get that everyone gets access to with support. And Trusted Advisor will give you a just an analysis of your actually several parts of your account. Costs and security are some of them. So let's take a look here at my S3 bucket. So you'll see that my four buckets, it's identifying the fact that this is our storage workshop bucket, the one that we're using for most of the demos. It actually has that, once again, that access that we would recommend and would not recommend. And so here's your it tells me where the access is, and it can actually do these scans, just like we said, do these scans and actually send out results. So this can create a proactive monitoring posture at a very high level. So this can go out to a variety, email list within the organization, and gives you some good criteria. Obviously, the idea is to keep lots of eyes on the security posture of your S3 account. I want to go back to our S3 bucket. So then we talked about, we talked about versioning, and versioning is a really critical piece of our data protection strategy. So I shared with you earlier a pre-signed URL, and it was for the bestfootball.html. That was the pre-signed URL that we looked at. And while he was presenting, I actually uploaded another version, and you can see it here. When we show versions, you can see that Lee and I had a bet. And the last team, Dallas and Seattle, played a couple weeks ago, and Seattle won. So I uploaded the new version of the same exact object, used the pre-signed URL to pull that up, and Dallas Cowboys don't rock anymore now. It's all about the Seattle Seahawks. And you can see that version was updated just a few minutes ago. And it's as we were preparing for this workshop, here's the number of times that we kind of updated that version. So you can see each time we upload, we've changed that, modified that object. There's a one of the questions in the chat was, how is that stored? So yeah, these 52 bytes are stored multiple times. In some of the other cases, not in this file, in the case of this file, I've actually used some of our other storage classes to migrate some of those files to older and colder storage. It's kind of outside the purpose of this demo, but I did want to show you that, hey, this can be done. Versions can absolutely live on different storage classes. So that's a pretty simple. And then last but not least, I did want to just walk through the S3 replication tab, just to show you where kind of where it's at. Once again, we're assuming this is a 200 level workshop. So our replication, a lot of our advanced features are here under management, and replication is one of them. And so we do need some additional steps to set up CRR in this account. And but that's pretty, and that's, like I said, that's one of the reasons we'll do this in another workshop. Lee, I think it's back to you.
All right, so I just want to go over our takeaways for Amazon S3 best security practices. I want to start with enable account level block public access. I am begging you. You do not want your company or your organization to be in the news because someone accidentally made something public that shouldn't have been. So please turn on block public access if you do nothing else. But you should do other things. You should encrypt everything. Use SSE S3 or SSE KMS. Use a bucket policy to enforce TLS. And send your secure traffic through VPC endpoints from your EC2 instances in your VPCs. You can enable object lock, versioning, and MFA delete to protect your data. And use replication, either CRR or SRR, for rogue actor protection. And then monitor your security settings using AWS tools. So thanks for watching.